Hi guys, welcome to another video, and today we're looking at alternating current. The current that flows through batteries or through solar cells is known as DC. DC just stands for direct current, which means the current flows in one direction. Current produced by generators or dynamos, or even the current that flows in the mains electricity, and that's the electricity flowing through our sockets at home. These are examples of AC. What that means is alternating current. And this means that the current repeatedly changes direction. If the current is constantly changing direction, it must mean that there's an alternating potential difference within the main circuit. In the main circuit, there are two main wires that we need to know. The first one being the live wire. And you also need to know about the neutral wire. Now, because there's an alternating potential difference between these two wires, it generates the alternating current. In the UK, the current changes direction 50 times per second, which means it has a frequency of 50 Hertz. The potential difference of UK mains electricity is around 230 volts. If you're doing the higher tier paper, you will need to explain how we use an oscilloscope to measure different parts of the wave. What we would do is we would connect a signal generator to an oscilloscope. Oscilloscopes just turn the alternating current or direct current into electrical waves. And you can see at the bottom here, I've given you an example of what typically would be seen on an oscilloscope. So this is my electrical wave. You can see on the y-axis we have voltage or potential difference, and on the x-axis we have the time. And you can see here that the potential difference constantly changes its direction. It's constantly being reversed. In your exam, you may be asked to measure the peak voltage. Now, the peak voltage is the height of the wave from the middle point of the wave. So this here is our peak voltage. And on the electrical wave I've drawn, the peak voltage is 325 volts. But you would be given any different electrical wave, and you're expected to calculate the peak voltage. You could also be asked to calculate the frequency of this electrical wave. To calculate the frequency, we use this equation at the bottom, which will be provided in your exams. We would do 1 divided by the time it takes for one cycle. Well, what is meant by one cycle? Well, one cycle is one complete wave. The time it takes for one complete wave. So from this point here, that's half a wave, and here's my full wave. The time it taken was 0.02 seconds. So to calculate the frequency, I would do 1 divided by 0.02. which would give me a frequency of 50 Hertz. If we connected a DC supply to an oscilloscope, there would be no changing in potential difference. There would be no reversing of the potential difference, which would produce an electrical wave that looks like this. In both cases, if we increase the potential difference of an alternating current supply, then you would see the electrical wave height increase. So for example, the wave would get higher. If we was to increase the frequency of this alternating current supply, you would see the waves become more squashed together. Okay guys, thanks for tuning in. Stay in touch for another video.